My name is Shalabh Agarwal and I work at Walmart. Today I'll be presenting on the custom operators, like how you can extend the out of the box airflow capabilities based on your needs. Quick disclaimer I would like to give. So whatever I'm presenting today, it's more about based on my learnings, what I have building different projects, open source over the internet. And I'll be skipping talking about what we do, how we do, very specific to the Walmart. Also, considering it's a third day and some of you might be get exhausted already, so I'll try to keep it concise and give a couple of some additional minutes before your next talk. So this is the agenda for us today. We'll be starting with why custom operator matter to us, why we need that, when to build them versus when to use, or there are lots of inbuilt or built-in options we have when to use them. We'll be discussing about couple of architecture patterns, how to create these custom operators, how to maintain them, and then I'll be showing you quick simple examples on how to create it, and at the end we'll be discussing about some of the real world use cases and some of the key takeaways from this presentation and talk. Sounds good? Okay, cool. So those who are new to this Airflow word, or probably these operators or custom operators, you might be thinking, okay, we have lots of inbuilt operators, right? Python, Kubernetes, and not just Airflow provided by the Airflow. There are lots of other vendors as well, like GCP, AWS. Everyone is rolling out their own operators so that you can integrate different services what they provide with the Airflow and do all of your work. So you must be wondering, why do I even need to build my own something, right? Because it comes with its own hassle. You need to do some additional work. You need to make sure, like, all the upgrades and all, right? So the reason being is, it's good to have or good to use all the built-in solutions, but most of the times when you grow in your organization, your project becomes very big. There are a lot of things what these built-in options would not be able to give you, right? For example, let's suppose, very basic example, you are part of a DevOps team and you are managing, or you are providing some sort of a managed service for your different horizontal users, where they can go and spin up some EC2 machines, right? And there would be a lot of org level policies what you want to enable or enforce on these all these EC2 machines, right? Which all these built-in solution might not be able to do, because these are very specific to your org, what your team has decided, right? So all these things what you can do, you can create some sort of a wrapper around what is the built-in solution you have, call it as a custom operator, and probably roll it out so that any users in your org or in your team who wants to create any EC2 machine or spin up any virtual machines in any of the cloud or the bare metal, right? So by default the existing or the default policies would be enabled, and ensuring whatever work is being done, it is following a certain standard and practices, right? So that's where these custom operators bridge the gap between a very specific need of the organization or a team versus what built-in was not able to do, and at the same time ensuring whatever decks you are creating, those are clutter free and easy to maintain and all. Because even if you don't create a custom operators, you can ask all of you users to um, enforce, write tons of lines of codes, to enforce all this policy, right? That could be one of the way. But writing a wrapper, build your own custom operator, make it available to all the users, that ensure whatever code rest of the peoples are writing, that is very clean and maintainable. So coming to this question, okay, so shall I be creating custom operators every time, or like when to choose built-in, when to start creating my own, right? So obviously answer is either neither a yes or neither a no. It depends upon use case to use case. Of course, ideal situation, you start with evaluating the existing solution. What are the built-in operators Airflow is providing? There are lots of providers are available, whether you are able to do your work with that or not. Also, you need to assess the your customization need, what kind of customization you need on top of that. Can you tweak the existing, or probably play with the configuration of the existing operators and make your work done, or do you really need a custom solution? So basis that sort of, you will be arriving whether you need a custom operator or not. So this is the kind of framework I generally use when to build my custom, which is on the left, and when not to use the custom or probably go with the built-in solution, which is on the right. So usually, if you are having a very complex business logic, like I mentioned, enforcing a lot of rules, org-wide rules, when you are creating any infrastructure in your cloud or bare metal or whatever environment you have, or there are lots of proprietary integration you need to do, which requires not just connecting with the different assets or the resources. On top of that, you need to configure a lot of things, right? And whatever all these things you are doing it in a repetitive way. It's not just one time you are doing it multiple times. Hundreds of users are doing on daily basis. So it's probably good to create your own custom operator. And of course, there are certain scenarios where, many times it has been seen using built-in solution might create certain performance bottleneck because of the way you are using and what your needs are. So in that case also, it's better to go with the custom operators, right? Versus if you are doing some standard operation, or it is just a one-time requirement, or probably your team is quite small, you will not be able to maintain it. There are some tight delivery timelines, or in all those cases probably you can go with some sort of a built-in or out of the box solution. So let's talk about the couple of architecture patterns, or probably some of the best practices how to create all these custom operators and keep them in a maintainable state. So this is not a complete list, but I would say a sort of a baseline list you can consider. So definitely, to start with, it should be a single responsibility. So whatever custom operator you are creating, it should be handling just a very specific task, not just you should be clubbing a lot of things inside just one single operator. Otherwise it becomes, basically you are coupling your system too much, and whenever you want to do any sort of upgrade, you want to change any logic, it becomes very difficult to maintain that, right? Second, it should be more and more config driven. Like you should be exposing parameters through constructor so that there are a lot of flexibility when users are using all these custom operators. Third one is the error handling part. Definitely whatever logic or solution you are building, it should be having a meaningful log, so that at the end you can do some sort of log analytics, you can do observability, you can capture a lot of metrics, and using that you can do a lot of things, right? And last but not the least, the testing and the documentation. Whatever you are writing, there should be meaningful unit test cases, proper documentation, so that even if your team is changing, so that anyone new person who is coming into the picture, he can easily adopt to it and start using it, and probably sort of keep on maintaining it. Coming to the some of the core components, so at very basic level or the principal level, how custom operator works, they inherit from the base operator which is provided by the Airflow, and they just basically override their execute method of this base operator class. And rest of the component, by design, basically they try to reuse what Airflow standard patterns are, whether it could be parameters, configs, connection, what is the runtime logic, how operator would work, or probably this deferrable property of the what base operator provides, right? So idea is just write your own custom logic, what the actual task or business logic what you need to do. The rest of the things, try to make a reuse of what Airflow is providing. So advantage is you need not to worry much about the how things are working behind the scenes, and it becomes very easy to maintain. And especially if you are a small team, and especially depending on what kind of team you are, if you are a DevOps team, definitely you can go into the Airflow core components as well, you can play with it. But if you are part of the development team, then mostly you are not much interested into all those kind of stuff, because that's not your area, right? Okay, so by this time you would be having question, okay, we understood what are custom operators, when to create it, some of the core components, how should I create it, right? So I've taken two example. One is very print hello, what we generally do in computer science. So as you can see, I'm creating a hello operator, which is extending the base operator class. Two things I'm doing over here. I'm overriding the init method, which is a constructor of the base operator class, as well as the execute method. So in init method, basically I try to initialize the base class or the parent class, as well as I usually define the what are the very specific parameters this new custom operator need, which is the name in this case. And second is the execute method, which essentially runs when in your DAG this operator is called, right? So this is the actual core logic where you would be putting what exactly you want your operator to be done, which is in this case is we are just printing a message, right? And the second snippet is primarily the how to start using it. So the first snippet I have, so let's say example, I've put it in a folder custom operator and I've created a hello operator.py file. That's how you create normal modules in the Python, right? And then in your next file or the deck file, you are just importing it and creating a using the deck context. You are just initializing this task and probably you can run it. Another example is like a custom file validation operator. Again, very simple to start with. Like the validation in this example, what I'm doing is how to validate the file size. Again, the logic remains same. You have to override the constructor method. You start with initializing the constructor of the base class and then defining the variables or the parameters specific to your custom constructor, which is the file path and the minimum size what you need to validate for this file. And in the execute, we are primarily again putting up some business logic, which is where first we are checking whether this file actually exists or not. If it does not exist, we are just reading some sort of an error, which is file not found. And then we are actually checking whether the file size is as per the input minimum size what should have been given by the user. And in the second snippet, it is again calling that operator with the different parameters. So I'm calling it with minimum file size of 1000 bytes. And in case when we'll be running this DAG in actual, so what in actual it will be doing, it would be checking whether this /data/user uploaded CSV file is existing or not, and whether the minimum size is 1000 bytes or not. Of course, this is a very basic example, but of course, idea is to give you more context, okay, how you can start creating it, and of course in the execute method you can write more and more complex logic basis your business needs. So now coming to some of the real world use cases where we can actually implement these custom operators. So one of the use case could be the data quality operator. Let's suppose you are working on building the data pipelines, you are generating lots of data sets, right? And one of the key area when you generate a lot of data sets is come up with some sort of data quality metrics, right? So immediately you generate some data set, you generate some metrics, you do some validation, right? All those stuff. So basis depending upon what kind of validations, definitely for each data set it may have different validations, but at least 50-60% of validation would remain for all of the data set. For example, whether data, if it is a daily pipeline, so whether data was generated today or not, whether it is having enough number of records, or probably we can do some comparison from previous day version of the data, all those kind of stuffs. So for this kind of a use case, probably we can create my own custom operator which we can run on daily basis, identify all these metrics, compute all these metrics, and probably find out if there is any issue in the data which is getting generated by the different data pipelines in the ecosystem. Another example could be some sort of an API integration suite. For example, you are again taking an example of data engineering world. You have written some sort of an ETL pipeline. You are interacting with lot of APIs, data APIs, and while interacting with the APIs, of course, you need to implement some sort of how to handle the errors, what should be the retry logic, ensuring you are not making depending upon the contract you have with that API, what is the kind of load you can send in a particular minute, or how many connections you can create, or all those kind of stuffs. So probably you can create a common logic around this, so that for all of your data APIs, users does not have to worry about all this error handling part, all this retry logic, and they just can use your custom operator and just say, okay, hey, I just need to call this 10 APIs and I don't want to worry about your error handling, which is something custom operator would be handling. Another example could be ML model deployment. We can create custom operators for model versioning, for model deployment, automated model deployment, and enabling the entire end-to-end ML pipeline management with the audit trails, right? So these are some of the use cases. Another use case which I mentioned at the start of the talk, the DevOps use case, right? So let's suppose you want to spin up a lot of infrastructure in your team, which is like use and throw. So definitely there are lots of policies should be enabled on this infrastructure. So some sort of custom operator you can create which enforces all these policies and ensures whatever is getting created in this ecosystem, it is as per the standard and everyone is following it without worrying too much about all these rules and regulations. So these are some of the key takeaways, I would say. So one is always make a strategic decision making. Evaluate whether do you really need some sort of a custom operator, because it always comes with a cost. You need to have a dedicated person, you need to maintain it, worry about all those upgrades and all. So always try to evaluate if existing solution work, that's always best. Otherwise, if it's very specific, let's go for building custom operators. Always, if you are saying okay, yes, if I've decided I'll be going with the custom operator, so yeah, always follow all the best practices so that it is in maintainable state, it is easy to maintain all those things. And yeah, always start simple, scale smart, start with a very basic thing and keep on incrementally build it and expand it.